Hello, hi students. So in this lecture we are going to discuss about the concept of isomerism, or what type of compounds we call it as an isomers. For example, I'm taking the molecular formula C2H6O. With this molecular formula we can write the two structures. One is CH3 CH2OH, an ethyl alcohol. Another is CH3O CH3, a dimethyl ether. The both ethyl alcohol as well as the dimethyl ether both are having the same molecular formula, but the structural formula is the difference, and their chemical properties are the difference, and their physical properties are the different. Why the chemical properties are the different? Because they're having the different functional group. Whereas in case of the ethyl alcohol, the functional group is an alcoholic functional group. Whereas in case of dimethyl ether, the functional group is an ether functional group. So coming to the physical properties, their boiling point is also different. In case of ethyl alcohol, boiling point is 78.38 degrees Celsius, and in case of dimethyl ether, boiling point is minus 24 degrees Celsius. It is highly volatile. Dimethyl ether occurs in room temperature in the form of the gas. Ethyl alcohol occurs in room temperature in the form of the liquid. Even though both are having the same molecular formula, their physical properties are different and their chemical properties are also different. So those compounds which are having the same molecular formula but different structural formula and different chemical and physical properties are called as isomers. I'm again repeating, isomers are the compounds, they are having the same molecular formula but different structural formula and different chemical and physical properties. The best example is an alcohol and corresponding ether are called as an isomers. So why alcohol is having the higher boiling point than the ether? Because in case of the alcohol, H bonding is present. In case of the dimethyl ether, there is no H bonding. Instead of H bonding, what was there? The dipole interaction. As we know already that H bonding is stronger than the dipole interaction, ethyl alcohol should have the higher boiling point than ether. Next, classification of isomerism. Isomers are classified into two types. One is the structural isomerism, the second one is the stereoisomerism. So what is the structural isomerism? Structural isomers will have the different connectivity. The connectivity between the carbon atoms inside the molecule will be different, whereas the stereoisomers will have the same connectivity. Connectivity is the same, but what is the difference in the stereoisomers? Stereoisomers differ in their arrangement of atoms in space. So these two we are going to study in detail in this lecture. First, again, the structural or constitutional isomers are further classified into different types: chain isomerism, positional isomerism, functional isomerism, metamerism, and ring chain isomerism. And stereoisomerism further classified into two types. One is the configurational isomerism, another one is the conformational isomerism. And the configurational isomerism further classified into two types, that is geometrical isomerism and optical isomerism. So in this lecture we are going to complete what is the structural isomers and different type of structural isomers. That's a chain, position, functional group, metamerism, tautomerism, and the ring chain isomers. Let us start with the structural isomers. Structural isomerism. Structural isomers differ only in their atomic arrangement in the molecule. Those isomers will have the arrangement of atom different. Their connectivity of the atoms are different in the molecule. Structural isomers possess the same molecular formula but different structural formula. As the name itself says, they'll have the different structural formula but they'll have the same molecular formula. First type of structural isomer is the chain or nuclear isomerism. So isomers are the compounds having the same molecular formula but different arrangement of carbon chain within the molecule are called the chain isomers. These chain isomers will have the same molecular formula but the arrangement of the atoms in the chain will be different. Let us take the example and discuss on this. For example, C4H10. Here butane, molecular formula of the butane. Here the first structure is having the 4 carbon atoms in the parent chain, whereas the second structure is having only 3 carbon atoms in the parent chain, and the 4th carbon atom came in the form of the branches. The first one structure is N-butane, the second one is the isobutane. So those structures where you are having the different number of carbon atoms in the chain are called as a chain or nuclear isomers. In the first structure, how many are there? 4 carbon atoms are there in the chain. In the second structure, only 2 are there in the chain, but both are having the same molecular formula. The relation between the first structure and the second structure is called as the chain isomers. I'm again repeating, what are the chain isomers? Chain isomers will have the same molecular formula. They differ only in the number of carbon atoms in the chain. The best example is the N-butane and isobutane. Let's go to the next example. In case of C5H12, here you are having the 5 carbon atoms and 12 hydrogens. In the first structure, you are having the 1, 2, 3, 4 and 5. You are having the 5 carbon atoms in the chain. What is the name of the structure? Name of the structure is N-pentane, or we can also call it as an pentane. In case of the second structure, what is the parent chain? So parent chain is 1, 2, 3, 4. Here you are having the 4 carbon atoms in the parent chain. What is the name of the structure? Common name is isobutane. IUPAC name is 2-methyl-butane. And in the third structure, you are having only 3 carbon atoms in the parent chain. So all these 3 structures are having the same molecular formula C5H12, but they differ in the number of carbon atoms in their parent chain. The first one is having the 5 carbon atoms in the parent chain. Second one is having the 4 carbon atoms in the parent chain, and third one is having only 3 carbon atoms in the parent chain. So what is the name of the third structure? Third structure's common name is what? Neopentane, and its IUPAC name is 2,2-dimethyl-propane. Let's go to the next example of 6 carbon atoms. 6 carbon atoms and 14 hydrogen. The first structure, here you can find the 5 different isomers. The first structure is having how many carbon atoms in the parent chain? Let us count it. 1, 2, 3, 4, 5 and 6. Here you are having the 6 carbon atoms in the parent chain. So whereas in case of the second structure, 1, 2, 3, 4 and 5, here you are having the 5 carbon atoms in the parent chain. As the number of carbon atoms in the molecular formula increases, the number of isomers are also increasing. For example, in case of C4H10, how many isomers are there? You can see only the 2 structures. Here you are having the 2 isomers. And in case of C5H12, you are having the 1 more carbon atom than C4H10. You can find here the 3 isomers, and in case of C6H12, you can find 5 isomers. As the number of carbon atoms in the parent chain increases, those number of the chain isomers are also increases. Now let us consider with respect to the boiling point. So now if you are comparing the boiling point of N-butane and isobutane, so boiling point is directly proportional to the surface area. As the surface area of the molecule increases, boiling point of those molecules also increases. In case of N-butane, you are having the 4 carbon atom, and in case of isobutane, you are having only 3 carbon atoms in the chain. Whose surface area is more with respect to the surface area? N-butane is having greater surface area than isobutane. So whose boiling point is more? N-butane is having more boiling point than isobutane. Now let us compare C5H12. In C5H12 you are having the 3 isomers. The first isomer is having the 5 carbon atom. Second isomer is having the 4 carbon atom in the parent chain, and third is having the 3 carbon atoms in the parent chain. So whose surface area is more with respect to the surface area? First one is having more surface area than the second one. Second one is having the more surface area than the first one. So what happened to the boiling point? Boiling point order is 1 greater than, 2 greater than 3. Okay, next, the chain isomers have different physical properties but same chemical properties. Just now I have said. So what about the physical properties? Their boiling point will be different, but their chemical properties and the chemical reactions are almost same. Why the boiling points are different? Because there is the change in the surface area. Let us go to the next isomer, positional isomers. So what are positional isomers? Those compounds are having the same structure of carbon chain but differing only in the position of multiple bond, that is a double bond or the triple bond, or a functional group are called as a positional isomers, and this phenomena is called as a positional isomerism. So let us discuss this by using some example. What is this name of the first structure? The first structure name is 1-butene because the double bond is on the first carbon atom. So numbering we are giving from right to left: 1, 2, 3, 4. Name of the structure is 1-butene. What about the second structure name? 1, 2, 3, 4. You can number this either side of the molecule. Either you can number it from the left side or you can number it from the right side. So name of the molecule is 2-butene. So both are having the same molecular formula. What is the difference between this first structure and the second structure? The difference is that in the first structure you are having the double bond on the first carbon atom. In the second structure you are having the double bond on second carbon atom. So these two compounds are having the same structure of carbon chain. That is, you are having the 4 carbons in a chain. So first one is having 4 in a parent chain, second one is also having the 4 in a parent chain, but differ in the position of the multiple bond. In the first structure you are having the multiple bond on the first carbon atom, and in the second structure you are having the multiple bond on the second carbon atom. So these two isomers or these two structures are said to be positional isomers. Let us go to the second example. In case of second example, we are having the functional group called alcohol. Here let us give the numbering for the alcohol. So functional group carbon will get number 1, 2 and 3. What is the name of this molecule? Name of the molecule is 1-butanol. Name of the molecule is 1-butanol. Here why alcohol group is having on the first carbon atom. In case of second structure, I'll name it from 1, 2, 3. Either side of the structure you can name. Why? Because you are having the functional group on the same position. So name of the molecule is 2-butanol. Both are having the same structure of carbon chain, that is both are having the same number of carbon chains in the molecule, both are having the 3 carbons. But what is the difference between the first structure and the second structure? Difference is the first structure is having the alcohol on the first carbon and second structure is having the alcohol on the second carbon. The difference is only just the position of the functional group is different. So what is the relation between these two structures? These two structures are related as positional isomers. Let us go to the third example. In third example, what is the position of the functional group? We have to give number 1 here. 1, 2, 3, 4. We have to give the numbering from right to left for this structure. Whereas in the second structure, we have to give numbering from left to right. What is the name of the molecule? Just guess the name of the molecule. Name of the molecule is 1-butanol. And here the name of the molecule is 2-butanol. Okay, so the relation between these two structures are also the positional isomers. So note, so positional isomers have the different physical properties but the same chemical properties. Why they are having the same chemical properties? Because so chemical properties will be differed only when there is a change in the functional group. Both are having the same functional group. If functional group is same, their chemical properties are also same. But why there is a difference in the physical properties? Because there is the change in the surface area. Here in case of this molecule, you are having the longest chain. Here the same molecule decreased its surface area. So I am going to repeat the positional isomers. What are positional isomers? Positional isomers will have the same number of carbon atoms in the chain, but they differ in the position of multiple bond, or they differ in the position of functional group. Just try with the example I am going to give. You can try with the triple bond, or you can try with any other functional groups. The third isomer is functional group isomers. These compounds are having the same molecular formula but different in their functional group. Molecular formula is same, but the functional group is different. Such isomers are called as a functional group isomers, or also we can call it as the functional isomers. There are a lot of functional isomers. One by one I have listed here. The first one is the alcohols and ethers. Alcohols and ethers always are functional group isomers, or we have seen this CH3 CH2 OH. Here you can find the 2 carbon atom, 6 hydrogens and 1 oxygen. What is the name of this molecule? Ethyl alcohol. What is the IUPAC name? IUPAC name is ethanol. Whereas the second structure is dimethyl ether, CH3O CH3. So both this alcohol and ether are having the same molecular formula, but where is the difference? The difference is in the functional group. In the first structure, functional group is an alcoholic functional group. In the second structure, functional group is an ether functional group. Coming to the second example, carboxylic acid and esters, C2H4O2. Carboxylic acids and esters are always form the functional group isomerism with 2 carbons, 4 hydrogens and 2 oxygen. We can write the molecular formula CH3COOH. What is the name of this molecule? Name of the molecule is acetic acid. And with the same molecular formula, we can also write the another functional group called ester. What is an ester? H. I am writing the open structure of this H. C double bond O, O, CH3. So difference is here the functional group is COOH. It's an acid. Whereas in the second structure the functional group is an ester. So what could you guess the name of the molecule? Common name is methyl formate. IUPAC name is methyl methanoate. The third functional group isomer is aldehyde, ketones and enols. C3H6O with 3 carbons, 6 hydrogens and 1 oxygen, we can write the molecular formula CH3. We can write the molecular formula CH3COCH3. Name of the molecule is acetone. IUPAC name is propanol. The same molecular formula I can also write an aldehyde CH3CH2CHO. The difference is here the functional group is ketone, whereas here the functional group is aldehyde. With the same molecular formula we can also write another structure called enol. Why I'm calling as an enol? Because double bond whenever is there we call it as an ene, and alcohol group we call it as an ol. So in this structure you are having the double bond as well as alcohol, so we can call it as an enol. So aldehydes, ketones and enols, these three all can act as an functional group isomers. Fourth one is dienes and alkynes. Dienes, what are dienes? En stands for you're having the double bond in the molecule. Di stands for you're having the two double bond in the molecule. For example, diene here 1, 2, 3, 4. What is the name of the molecule? 1,3-butadiene. What is the molecular formula? C4H6. So with this same molecular formula, instead of writing the two double bond in the structure, I will put the one triple bond here. So what is the name of this molecule? 1, 2, 3, 4. What is the name? 1-butene. Always dienes and alkynes will also act as a functional group isomers. And the next one is nitroalkanes and alkyl nitrites. C6, sorry, it is C2H5. Here CH3 CH2 NO2, we'll call it as a nitroethane, and here we CH3 CH2 ONO2, we call it as ethyl nitrate. What is the difference? Here the functional group is NO2. Here it was attached to the alkyl group through nitrogen atom, but here the functional group is ONO. It is attached to alkyl group through oxygen atom. The difference was there. What is the difference? The first one is NO2, second one is ONO. First one is bonded through nitrogen, second one is bonded through oxygen. The next one is amines, primary amines, secondary amines and tertiary amines. So what are primary amines? If nitrogen is attached to only one alkyl group, we'll call it as a primary amine. What are the secondary amines? If nitrogen is attached to the two alkyl group, we call it as a secondary amine. And tertiary amine, if nitrogen is attached to three alkyl group, we'll call it as a tertiary amine. Or we can also classify like this. If nitrogen is having the two hydrogen, we call it as primary amine. If nitrogen is having only one hydrogen, we call it as secondary amine. If nitrogen is having the no hydrogen, we call it as tertiary amine. So primary amine, secondary amine and tertiary amine, these three structures are having the same molecular formula. They differ in their functional. And the next one is cyanides and isocyanides. Cyanides, CH3CN. CN is the functional group. Isocyanide, NC. NC is the functional group. We call it as methyl cyanide. This is the methyl isocyanide. Next one is aromatic alcohols, phenols and ethers. Aromatic alcohols. For example, here I'm going to write methyl here. What is the name of the molecule? 1, 2, 3. 3-methyl phenol. Here the functional group is phenol. Here it is not the phenol. Why? Because OH was not directly attached to the aromatic ring. In between, what was there? CH2 group was there. So name of the molecule is benzyl alcohol. And another isomer is anisole. We call it as this structure of the molecule. And name of the structure is the anisole. Or we can also call it as methyl phenyl ether. aromatic alcohols, phenols and ethers. These three can act as a functional group isomers. Now, functional group isomers have the different physical and different chemical properties. Why they're having the why they're having different physical properties? Because they're having the different functional group. All the isomers are not having the same functional group, they're having the different functional group. So because of change in the functional group, their physical properties are also changing and their chemical properties are also changing. Metamerism. What are metamerism? So metamers or the compounds are having the same molecular formula but different number of carbon atoms or alkyl group on either side of the functional group. For example, in this, what is the functional group here? Ether. In this molecule, left side of the ether, you're having the two carbon atom, and right side of the ether you're having the two carbon atom. But here with the same molecular formula I can write in another ether where left side you're having only one carbon atom in the chain, right side you're having the two carbon atom in the chain. So these two are called as metamers. So what are the metamers? Metamers will have the same molecular formula, but where they differ? They differ in the number of carbon atoms on either side of the functional group. Here functional group is either here having the two carbon and two, whereas the functional group here is also either you are having one and three carbon atoms. Clear? The same thing we can see with the sulfur. Here two carbons, here two carbons, another isomer. Here I can write 1 and 3. Same we can see with the amines. Around the amines, here you are having the 2 here, and here having the 2, but here you are having only 1 carbon and 3 carbons. So what are the metamers? Metamers will have the same molecular formula, but they differ on the number of carbon atoms either side of the functional group. First let us, now metamers have the different physical but same chemical properties. Why they are having same chemical properties? Because they are having the same functional group. Ring chain isomers. Compounds are having the same molecular formula but possessing open chain and cyclic structure are called as a ring chain isomer. First let us start with one example, C3H6. So for C3H6 I can write structure this CH3 CH double bond CH2. We'll call it as 1 propene with same molecular formula. For this I can also write a cyclopropane. Here these 3 carbon atoms are in the open chain, but here these 3 carbon atoms are in a ring. The relation between these two structures are called as a ring chain isomers. And another formula is C4H8. We can write 1 butene, cyclobutane, methyl cyclopropane. These 3 are also called as a ring chain isomers. Okay, so this is the end of this video lecture. So I have picked up some question on those topics which just I have given the lecture. Just solve these questions, and if is there any doubt you can call me and ask.